Welcome, colleagues, to the this International House event today, and welcome to those colleagues who are joining us online. We are now ready to convene. Thank you very much for those of you who are joined online, who have been waiting probably with bated breath for this conversation today. Let me give you a few bits of housekeeping. We are hybrid today, so if you have joined us online, this is a webinar, so you have access at the bottom of your screen to both a chat and a Q&A function. We will monitor those throughout the talk today so that your questions and discussion can be fed into the wider IAS seminar. So do use those and do feel free to use those. You don't have access, however, to your microphone and or to your camera. So if you're wondering why you don't have access to them, the reason is because they are not part of the webinar version. We are very, very pleased today to be hosting this event, and it's wonderful to see a live audience here as well at this time of year, as well as having some people online. To welcome Dr. Emrullah Hakan Kaleli, who is joining us today from the Yildiz Technical Institute in Istanbul, and he is an esteemed scholar, and a scholar that we are both very happy to welcome and to continue the collaboration that you're having with Mahdi Mohammad-Pour, who is going to do your more formal introduction. But also, we're very glad that you made it, because we know this was not an easy journey, and we are very, very thrilled to see you, and are really happy that we're hosting it today and that we are all here and able to be present. So without further ado, I'm going to turn over to Mahdi, and you're going to have a bit of a conversation as introduction and explaining a bit about what your collaboration is as well. Thank you.
Thanks, Marsha. Good afternoon, everyone, and welcome to this IAS presentation. So today is my pleasure to welcome Professor Kaleli, who was effectively backbone of the collaboration with Yildiz University. I just want to very briefly mention how we got to know him and his team, and why we just found synergy to do further collaboration together. And hopefully this visit will be the stepping stone towards next steps. So Professor Kaleli, first of all, we knew him because he organizes a conference called Deposition that is biannual, and it attracts wide range of researchers, but everybody is somehow related to the field of tribology, which is our field. So and we got to know him, and also his the event, which was fairly successful, attracting researchers from all over the world, and made a good platform for networking and building new relationships. And then last year I visited the lab, and as part of our visit we explored different subjects that we could use as platform for our collaboration, for doing common research and collaborative research. They work on coating, which is mainly used for powertrain application, more specifically engine and engine conjunctions. Was very attractive, and they show very good enthusiastic team, nice level of technical side, as well as very nice atmosphere that they have there, which is appealing for people like us who want international collaboration and widening our international reach. So that's how we got here. We started our collaboration. They did some work on graphene oxide and reduced graphene oxide coating of engine components, which is, I believe, part of the presentation today as well. And then we invited Professor Kaleli and IAS, Marshall, and other colleagues were so kind to support this application, and now we have Professor Kaleli here. So as part of this visit, we will give him a tour of our facilities, similar to what I had in their university, and hopefully we will explore the more possibility. So most colleagues who are here, actually all colleagues who are here, are part of our wider team. So we all work on tribology, either directly or that is part of our work, which means we hopefully have good potential of expanding our collaboration, which is not necessarily between our group and Professor Kaleli's group. We may explore opportunities in general between Loughborough University and Yildiz University. Yeah. So, and I thank again for IS team's great support. As Marsha mentioned, it wasn't easy to get here because of loads of visa application process and so on, very last minute. But now we are here. And it's my pleasure to hand it over to Professor Kaleli for presentation.
Thank you. And so I am Dr. Emrullah Hakan Kaleli from Mechanical Faculty, Mechanical Engineering Department, Yildiz Technical University, Istanbul, Turkey. And I am very glad to collaborate with Prof. Dr. Mahdi Mohammad-Pour from Wolfson School of Loughborough University in UK here. Well, just you see my short video. My main field is internal combustion engine because I am in automotive engineering department, but now the engineering department is belongs to the mechanical engineering department, so the name is changed. And I am teaching gasoline and diesel engine tribology, where lubrication and friction. I'm working still on engine tribology, nano tribology, lubrication, friction, wear, engine oils, additives, coatings, drain intervals. My PhD was about on lubricants, additives, and additive layers on the surface, oil drain intervals in Turkey. And I am very interested on surface analysis, nano-additives. For nano-additives, we finished last year with South Korea a project of reduced graphene oxide, which was suspended in engine oil. It's very important. The oil, the additive, must be dispersed, well dispersed, and should be in colloidal form. And we have succeeded it. And then we finished this project. It was for 2 years. I have finished also a project with TÜBİTAK. We have institute, Turkish institute, big institute in Turkey, which collaborates with different countries, not UK, but like Germany, Tunisia, France. So I got a project about coating of graphene on pistonings. It was with a CVD method. We succeeded it, but the CVD method is when you coat it, it's very high temperature and there is a distortion of pistoning, but we succeeded. Then we tried to coat engine liner with the same nanoparticle, and we succeeded here. So I am a member in the scientific committees for many conferences in advisory committees, and I joined to many international conferences like in South Korea, Tunisia, Taiwan, and we presented a lot of papers. You see here in our website, ISIS, all my details, and you see my email, and I have 2 emails, one university email and the other one Yahoo. You can see my phone number. I'm sorry, I don't use WhatsApp, but I use Skype here. So it's better because I have some difficulties with bloody people and with a lot of students. Okay, I would like to talk about Turkey trip conferences. So you know what is tribology? The science and technology of surfaces interacting in a relative motion. It comprises the entire field of friction and wear, including lubrication. So it is multidisciplinary field by nature. It has been the possibility to discuss in that conferences the experimental results obtained from the research carried out in Turkey, and different universities participating from different countries in Turkey trip conferences. So we combine tribology with all over the world. As I am dedicated to tribology, I am teaching tribology for undergrad and graduate students for many years, since 1998. I am working mostly experimental, not numerical. Since 2015, I organized Turkey trip conferences. And in that conference, more than 100 participants attended to the international conference on tribology. Each time it was in Istanbul, Turkey, with high quality plenary and keynote speakers from different countries like So you see all the countries: Algeria, Azerbaijan, Australia, Canada, Bulgaria, France, Georgia, Greece, Germany, India, Iran, Israel, Malaysia, Romania, South Korea, Switzerland, Turkey, Tunisia, UK, Uzbekistan. Special issues published in international journal. And also, for example, it was one of them, Industrial Lubrication and Tribology. The first conference, it was in 2015, which was in my university. You see there just the poster of the conference. So on the picture you see our university, and you see the Bosphorus Bridge. Bosphorus Bridge connects the European side and Asia side. So I live in Asia side, and I cross every day. I go every day to passing this bridge to European side.
But no visa.
Without visa. Without visa. Without visa. Yes, but I can go to Europe also without visa because I have got special passport, green passport. But for UK, I need visa. Hopefully, I got it. You see on the just top left side, just my university. My university has got two campuses. One is in Beşiktaş, in European side, and the other one is Davutpaşa. In Davutpaşa, the size is much more bigger than Beşiktaş, and we are growing up. So Turkey trip 2018, it was in April, and you see the sponsors from Shell company, Loughborough Lubrication, Castrol. Eri Motor is one of the engine company. UTS is they sell Turkish tribometer, but it's not good quality. I don't like it. My tribometer is much more better. I will show you. And also Carrefour industry. Carrefour sells. It's a representative firm. Sells optical profilometer and microscopes. And also Nikon also was sponsored for this conference. And also there is a Tribological. Tribological means research and development in tribology. This is a company in our technopark in Istanbul, Turkey, in Davutpaşa. We work together also with this company, and we had also a lot of awards on nanobaric acid nanoparticle added in engine oil. We succeeded it, but we have not used it. It was not useful. I can explain later if you like. Also, some other top polymer companies from abroad joined to the conference. Turkey trip 2022, it was successful, but you know that time was COVID-19, so we did online this conference. The other conferences were face-to-face. Well, this year, on May, also we organized a conference with Promet company. Promet company is in the technical part and just sponsored us, and many participants came here. And it was that time in Anatolian side. It was in, you see, Maltepe Yaşar Kemal Cultural Center. We had very great conference. And a lot of keynote speakers came in, like, for example, I know he is my very best friend from South Korea, Prof. Dr. Dayan Kim. He is in Seoul in Yonsei University. What we did a project with him, and it's over. He has got in Seoul, Yonsei University has got a nano center of wear. And really, we had bloody, very potential collaboration. And I wish to do with Loughborough University also, if we can. I will be very glad of it. And so the next conference will be in 2025. So please welcome. And I will inform Prof. Mahdi Mohammad-Pour, and you can have all information. And if I can have your visiting card, then I will inform you also. Okay, my presentation is about the development of reduced graphene oxide coating for engine cylinder liner by electrophoretic deposition method and evaluation of its tribological performance. Here, I would like to show you about some information of my Yildiz Technical University. This is English. You can see on the website. If you like Yildiz Technical University, you will find it. That I will show you shortly. You see, now our university is in the fourth in Turkey, in the fourth range. It was five, but now it is in the fourth, and we are growing up. We became research university in Turkey, and I hope we will be the first. And we go to the third. We can find, explore here the education. We have R&D. We have, for example, more than 300 research laboratories and 20 thematic research groups, 30 research and application centers. And we have a co-op model. Co-op model is for undergraduate students. It's a very, very good model. Students can go to the industry, and we do cooperation with the industry. They get courses there, and also they get habit, and they work manually, and they learn mechanical engineering. It's a half session, like 4 months. And it is when they finish, they pass the courses. But it's a very good collaboration. This is where I am in Beşiktaş, in European side, one campus here. And we have Erasmus program. Also for Asia countries, we have Farabi and MEME programs. So the students and most students, foremost students, but also teachers also can visit, can exchange programs. We have 2,000 graduates, and 55 number of the students provided financial support during Ramadan feast. Okay, now I stop here because it's okay, I will stop here. Just close. Yeah, okay. I will show you just some small short video of my university.
Yildiz Technical University, with the vision of being a leading institution of international standing, represents a unique milieu of education, research, and culture in Turkey. Yildiz Technical University inherits our outstanding science, technology, and culture, pioneering open access to academic research, technology, and the arts. In addition to its academic standing, Yildiz Technical University offers its students a lively social environment. Student clubs that take part in various activities ranging from volunteer projects to extracurricular entertainment and educational events.
Just I want to tell you some small things. I think I heard that Loughborough University campus is the biggest campus in Europe, isn't it? But it's unbelievable. It's very nice. But I think,
as well as a broad variety of cultural and artistic occasions, give students the opportunity to lead an active academic life. Being one of the most well-known universities in Turkey, it is conducive to the achievement of the goal of the development and welfare of society. Yildiz Technical University, one of our leading government institutions, is situated on 2 campuses in Istanbul. It is the 3rd oldest university in Turkey, with its history dating back.
So every year, if the profs or all, we call it enseignants, all teachers, if they do high quality papers like Q1, Q2 in Scopus, our rector gives us an award, a certificate, and also they gave us some money just for remuneration. It was 2 months ago, I got one.
To 1911. Today, Yildiz Technical University has 11 faculties, most of which are related to engineering, 2 graduate schools, 3 vocational schools, 1 school of foreign languages, and more than 34,000 students. Yildiz Technical University offers a range of programs at the undergraduate and graduate levels. From the science and engineering disciplines to arts and humanities, it also provides opportunities for qualified students and academicians to participate in exchange programs. In line with the 21st century entrepreneur university model, while making contributions to research and development.
This campus, you see, is a very big campus, and we bought it. It was soldier kazan, soldier houses, and now it's Yildiz Technical University. Yeah, military. Yeah.
Activities in our country, Yildiz Technical University commenced operations in certain technological development areas and founded Yildiz Technopark in 2003. Yildiz Technopark hosts more than 7,500 research and development companies in many sectors, such as software, information and communication technologies, electronics, the pharmaceutical industry, the machine and equipment industry, chemistry, the aviation industry, the defense industry, civil work, and the food industry.
Okay, I want to show you some more video, then I will continue my speech.
Rector and Director, members of the faculty, I'm very pleased to be here.
Oh, sorry, that next one. Yeah. So we have also got talks as he is doing here. Just I would like to show you some more talks. You can find in the website lot of talks like we have also this opportunity. And if anyone wants to talk, please welcome. I can introduce to my university. Now I go a bit more, I do more science. The outline of this speech is this. I would like to inform you about this collaborative research between Yildiz Technical University in Turkey, Istanbul, and Loughborough University, Wolfson School. The importance of this collaborative research work. Preparation of single liner specimens for coating and trial test. Method preparation of graphene oxide coating on any single line. And successful coating with RGO, reduced graphene oxide. Tribal test procedure. Tribal test video of samples. And surprisingly, not only we work on RGO, but also we have been successful to coat with multiple carbon nanotubes. And in the future, we want to coat multi-layer. We wish to coat multiple, like we coated, for example, reduced graphene oxide on the top, multiple carbon, but it didn't work. Now we will try first multiple carbon, then RGO. I think we will be successful. We will see in the future. Friction, we have some friction test results. I will show you shortly. And the edit value. Edit value is the collaboration with UK side. As we have two high potential, and we want to join to combine these two high potential for collaboration. And next step is engine test. Acknowledgements. Okay. Information about all collaborative research work. So you in the website we have seen also this one. So this is collaboration between two universities and to quote RGO liner. So I don't want to repeat everything at the same time. And the tribological impact of RGO coated engine single liner will be compared with an uncoated diesel engine liner with EPD, electrophoretic deposition method for low friction, better lubricity, and high wear resistance. Its tribological performance will be evaluated through a reciprocating tribometer then engine test. First, we wish to coat engine liner with different coating thickness, then test in tribometer and see if the coefficient of friction is less, then the optimal coating test in engine. This is our main idea. So as a methodology, two sites will perform their potential for high quality publication. So of course, for a good collaboration, we need to publish in high quality papers. A Turkish site will perform coating process by using APD of RGO, and also I can add multiple carbon nanotubes. And UK site, just we wish they carry out some surface analysis of coated single liners with RGO to investigate if there is a reduction in friction, corrosion prevention, and increase in service lifespan of this engine. The importance of this collaborative research work. So you know, we have 100% of energy, and only we obtain 40% as indicated work. And 25% of this indicated work is mechanical losses. So what happens? 10% of mechanical losses, we obtain mechanical in 10% of the total energy. And only according to Dr. Lang, so you see the paper here, the friction losses comprise 7 to 5% of the mechanical losses. What you see here, connecting rod bearings, main bearings, pistonings, valve train. And you know, the most wear mechanism occur at the top dead center between when the pistoning and cylinder liner rubbing together. And you see the piston friction is 75 and piston is 19. So it's almost 45–50% of friction losses happens there. And most of them, according to my experience, it happens at the top dead center of engine. So the importance, well, in terms of total energy saving in internal combustion engine, a 10% reduction in friction losses is estimated full economy between 1 and 3%. But the importance here comes from powerful collaboration. If we can cope with RGO or multiple carbons, it's the second option, then we can collaborate. In our lab, we have a single cylinder diesel engine, 6LD400, and you see the engine specification here. It is produced in Anadolu Motor Group. It's a big company in Turkey, and we have this engine. So you see why EPD coating? Why electrophoretic deposition? Because you apply energy voltage, and the coating can be done between 1 and 5 minutes or 10 minutes for multiple. And it provides homogeneous coating surface. By extending the time, you change the time, and the coating thickness can be variable. And it's a low cost. You can see some papers here. So we have this cylinder line is dry cylinder line sleeve. It's a cast iron, and the Lego coating is can be done on that surface. You see the technical drawing. This belongs to the Anadolu Engine Group in Turkey, in Istanbul. So it's a dry cylinder liner. You can change the liner. So we can have spare parts. And what we did, for tribo test, we cut it without damaging the rubbing surface, horn surface. We cut 10–30 millimeter dimension to fit in tribometer here. This is cylinder liner surface. And the cutting process. So we collaborated with the industry. I have got a good collaboration with in this with Dünya Limited in Turkey, and they used CNC milling process technology without damaging the horn surface. They measured the temperature not exceeding 49 degrees Celsius, and they cut in dry cutting process. And they cut very well, 10–30 millimeter dimension, and it is well fit in our tribometer. So the method, for the method, we bought graphene from Graphene Biotech company. It's in other city in Turkey, in Konya. So you see the specification of graphene here. So we made graphene in powder. But for EPD process, we need the isopropanol and magnesium nitrate. And we bought also this one, good quality, matte quality. You see the graphene oxide here, reduced graphene oxide. And for the process, we have 4 steps: dispersion, electrochemical charging, as you know, electrophoresis, and deposition. So we use this receipt from the literature here, from this paper. So we have RGO powder, and we have isopropanol. We mix isopropanol with RGO powder. Then we add the magnesium nitrate, and we have EPD process. Then we coat engine cylinder liner here. I will show you later. Well, first of all, we prepare with graphene with isopropanol solution. And the duration of magnetic hot polyester and ultrasonic cleaner is 1 hour, 30 minutes, 30 minutes. It should be well dispersed, well in colloidal form. Total 30 minutes. And also, then after we add the magnesium nitrate, well, we know the amounts according to the receipt, literature survey, and with the mixture of graphene isopropanol is mixed with magnesium nitrate here, and still in magnetic hot polyester. Also in ultrasonic cleaner. So stirrer ultrasonic cleaner with magnetic stirrer ultrasonic cleaner. The thing is, the solution here is getting hot. If it is getting hot, you cannot proceed the EPD process. That's why we use the ice to keep cold the solution. That is very important. Now I will show you graphene isopropanol with multidiscipliner here. Then ultrasonic cleaner. Magnetic stirrer and ultrasonic cleaner is very important. If you don't do it, you cannot succeed. It's very difficult. Then we added, according to the literature survey, magnesium nitrate, enough amount. You see the color starts to change. Then magnetic stirrer 30 minutes again. So this total is 1 hour, so 2 hours. So we need ice here. It's getting hot. For this process, you can have power supply. There are different kind of power supply, like, for example, 30 volts, 40 volts, and it is not enough. Because as we use, the metal is cast iron of engine line, and 30 volts is not enough. So we had to buy a consort EV from Belgium, which is can go up to 1,200 volts. Yes, some voltage in our lab was yes, variable. So for example, in this process we used 4 minutes, 21 milliampere, 23 watt, and 1,200 volts. So you can see here. You see the coating process, and to able to coat, just we isolated the pieces of lining. If you see bubbles in 1,200 volts, then you understand you will be successful. Just I show you, we coated some, but we will continue our collaboration and to obtain, for example, different different thickness from nanometer to the micrometer. It can go up to 6 micrometer. You see 1,200 volts. Different thickness, different shapes. And so at the end, we obtained reduced graphene oxide coating on the engine liner. You take off the isolation of silicone, and you can test on the tribometer. Well, here you see the coating of 3 minutes, 4 minutes. And we have also 6 minutes and 2 minutes. We have more. So my tribometer is a custom-made tribometer. It's very sophisticated. It can have 800 data per second. The heating is up to, here we use the procedure, 99 degrees Celsius with 30 Newton and 21 minutes. Why 21 minutes? Because when I speak French, I have been in France, Lyon, at INSA many years ago, and I work with Mr. Yves Berthier at INSA Institute. As I speak French, we collaborated together, and we tested on tribometer at INSA these parameters. Why these parameters? Because we like to obtain additive layers, just cover all the surface on the liner or on the sample what we are carrying out. That's why I experience for one lubrication condition for this type, this procedure. And if you exceed more than 21 minutes, 30 minutes, the friction is steady. So we stop there to see what happens on the surface. And we use mostly, we have used before real pistonings on the liner, but it doesn't work because the holder, we cut small pieces, the pistonings, and if you set up, it was 1 micron or 2 microns, the results all are different, and also the shape of the pistonings, you know, there are different types. They are changing. So we produced specially ball holder and ball with 8 millimeter. Just we obtained contact point, and here in that tribometer we tested different kind of lubricants, nano lubricants, nano additives, etc. That's why we use ball on block system. And you see the cylinder liner here, 10 and 30 millimeters, as we cut in the industry. But I will show you just small example of my tribometer. It's very sophisticated, and we did program also. The temperature is 100 degrees Celsius, and you will see that just the signals up and down, so you know, reciprocating, and we obtain 800 data per second. And in that case, 640 because the stock is 8 millimeter. So next step is this was for reduced graphene oxide. Now also we tried, surprisingly, this is also a PhD thesis of my student. He's working very hard. He is good. We tried also with multiple carbon tubes. Just before to come here a month ago, we started almost in 2 months. So we bought a multiple carbon tube from Arkema, and you see the specification in. But for the solution is different. We found the receipt, the article, and we need sulfuric acid, nitric acid, and deionized water. Then you can do coating with those ones. So the preparation is just first of all mixing nitric acid, sulfuric acid mixture. Then adding carbon in that mixture, and stir in manual stirrer at 130 degrees Celsius for 30 minutes. So you obtain one solution. Then after you add very small drops of this solution in deionized water. Then you can do EPD process. So you see, this is magnetic stirrer, and after ultrasonic bath process, then we use magnetic stirrer. This is first solution with sulfuric acid, nitric acid, and multiple carbon. So you obtain this heavy solution. Then you must use few drops of this solution in the deionized water. But we did here one drop. If you increase the drops, it doesn't work. So after many experiments, we have succeeded this. Well, the voltage is that time is 40 volt, and just when you see the distance is 1 or 2 centimeters, no more. So we spent, for example, 2 centimeters, it didn't work. Then we did many tests, but we spent a lot of samples. We lost, but we obtained. So you see multiple carbon coated surface. Then it's ready for tribometer. Just before to come here, we did some tribo test results. And in my tribometer, we have very nice program. As it is reciprocating, it takes the average of all data. We have million data here, as in 1 second is 800 data. And it gives us the average of curve and also the shape. You see here the red one is RGO and the other one is uncoated. And here you see the multiple carbonated also, and multiple carbonated was less than uncoated one. But the multiple coating was 10 minutes, 9-10 minutes. It was not 3 or 4 minutes. You cannot succeed in. So this is uncoated, multiple coated, and RGO coated. So as a coefficient of friction, you see the result here. So uncoated, it was this one, and it's getting this up to RGO. So RGO is much more, is much better than multiple coated. So the curve is decreased as 26% for RGO and 147% for multiple carbon. The error data is 0.1, this one, not 1, 0.1%. So almost 1 by 1,000. Next step will be engine test, if we can collaborate, I hope. For engine test, we design a special device just to install or cylinder liner, cylinder sleeve in that procedure, and we obtained it. We did. So you see our device, but we have not coated yet, and we will coat in the future because we don't know which one the best thickness and which one the best coating procedure. So this is, we have engine dynamometer, we have control panel, and also we can do motoring tests, just drive the engine outside. And well, for engine test, sorry, we can have engine performance test, and we can do engine life test, like power, torque. We can obtain all data in that device, in that control panel. We can control it. So just I would like to show you on my X presentation, old engine working. we have all information for when we are doing engine performance test. We can draw torque and power according to the revolution. So added value collaboration with UK side, what we are thinking, the high potential with 2 Ford universities. Okay, UK side will carry out surface analysis of coated lines, single liners with RGO, I hope. So I have samples, I got samples with me, and we can continue our collaboration. I can live here, or we can start as much as you like, whenever you like. I have non-coated and coated samples. Even just small introduction here. We polished also the home surface because the coating can be done better than according to the home surface as it's machining mark. It's a bit difficult. We succeeded, but I have also samples, non-coated samples, just to start. So your potential is here. First of all, I would like just to ask if it is possible. Coating thickness is important for us to see if my samples, what about the coating thickness? If we learn the coating thickness according to the or coating time, then we can progress better. And SEM ADX or FESM, Raman spectroscopy, AFM, and laser confocal for surface roughness. And if it's possible, corrosion test. We need to measure, of course, wear resistance. It's important. Well, so I would like to thank so much to Prof. Dr. Mahdi Mohammad-Pour just giving the possibility of this collaboration. And also, I'm sure it will be very fruitful for both sides. So great thanks to Prof. Dr. Marsha Benskilman, Director, Institute of Advanced Studies here for invitation letter. Hopefully I could get visa to come here. And we are together now. I'm very happy to be here. Thanks also for help for Kiran this day, okay, for his support in IAS activity, and also Ms. Laura Day providing invitation letter also to Bhavna Patel for travel arrangements. Thank you very much. So great. So thank you for your attention.